The next thing for us to discuss is going to be a third facility or third mode which we should be able to recognize when we're working with files, which deals with random access files. And you're probably going to need random access files if you again program your own version of a small database. So random access files suggests that you should be able to open the file and then navigate through the content of the file and be able to specify where exactly you want to go to read and write data. So it comes with its own territory, and in Java you would use a separate there are actually two possibilities to go with. The file channel would be one class that you use, and random access file class is another choice that you have. If you compare it with the C++ standard library, there you just open the input-output file in binary mode for reading and writing and random access, and it really doesn't present there any new classes. But in Java, random access files are covered by a separate set of library API and classes that we need to use. All right, so far everything that we did was essentially write, and then read. Everything was sequential. And so sequential access to files allows to access records sequentially from beginning to end. Good for any kind of batch processing, basically having a console program that sequentially processes lots of data. However, databases may need a different approach to accessing the data and both storing and retrieving the data. The sequential access is good for multiple records and processing them sequentially. But if every time to locate the record you need to look sequentially through a set of records, unfortunately this is inefficient because it could be a long file and you'd be wasting your time every time searching for a specific location. But if you already know where your record is located, maybe you could jump directly to that place. And so real-time applications such as databases require this immediate record access, and this is what we're going to cover in this presentation. All right. So comparing sequential versus random access files. So just maybe if I could go to my scratch pad right here and maybe talk a little bit about this very quickly. So I can have a file. Which contains records, and those records could be exactly the same size, just like this, right? I can have these records in a file, and they can contain multiple fields of data, just like this. All right. Then my option is to sequentially read one record at a time, and this is what we did. Or maybe I can say seek a particular position and go directly at the record that I want without the need to read sequentially. Just basically seek and then read after finding my record. So that would be random access. And of course, random access, you need to realize that if there is more information in this file and there are more records in this file, then if I want to update this record and store new data in this record right here, then I have to watch out carefully not to overstep the bounds of my record, because I will be damaging information in the next record, right? It's okay for me to write smaller amount of data in this space if it already exists, but not more than the actual record size currently is. So I need to be careful with additional things to sort of like worry about. All right, so let's see. In random access mode, records can be located in any order. Sure enough. Direct access to or instant access. That's other types of, terms that people use to talk about random access, but random access is kind of more standard. And we have to manipulate this imaginary pointer, which points to the next record that could be either written to or loaded, basically the information that we can read. And there are two ways to achieve this functionality. There's file channel, and there's also random access file. So the random access file is an older facility, and the file channel is newer Java facility. So both classes allow reading and writing. File program can search for specific location in the file. So let's see what possibilities do exist. So the file channel is a facility where we can say, with the file channel, what we can do is we can use a file channel to read and write data, and you have to say open. So this is similar to what we saw with basically constructing our file input, file output. You'd have to open, and it does accept the options that we already discussed. Right? You can query what the current position is. You can also specify the new position, passing in 64-bit integer, long integer, to specify where the new position you would like to be if you'd like to navigate in the file. And then you can read into the byte buffer. Byte buffer is a helper object which basically maintains a sequence of bytes in memory. You can also find out what is the size of the file, and you can write from the buffer. So these are the options that you have. And so an example here says that if you need to position, basically the calculation is that you need to know what your record is in record size is in bytes. If you're using a file with uniform size records, and what you need to do is basically make it zero based. So if you need to go to read record 1, you need to say 0, position 0. If you need to read record 2, 2 minus 1 will be 1. 1 times record size will give you position for the second record. So anyway, so records are typically in database world are numbered 1, 2, 3. As opposed to 0, 1, 2, 3, and so forth. So they're 1 based as opposed to 0 based. So we need to do this quick conversion from 1 based to 0 based in order to specify the record locations, right? So in our examples, we will assume that every record has the same size. All right, so let's see if we can look at some of the sample code. Now, we've seen a string buffer, if you recall. String builder, string buffer were helper objects which were helpful in maintaining strings which were basically variable in size. And string builder would be our typical choice for that. So here's a byte buffer, which is kind of similar to these because it's a helper object. So what happens is that before you can use the string, in order to say you want to output it into a file, what you need to do is that you need to construct the byte buffer, and the byte buffer has this static function named wrap. And when it wraps around the data, essentially it reconstructs the byte buffer. It's a mutable object. Once the byte buffer is constructed, you cannot change it. Every time you need to change it, you need to wrap around it. And remember, with the file channel, you just have to say write. And what happens is that the wrap method requires basically a raw array of bytes. And we can ask the strings for the raw array of bytes by simply saying get bytes. Okay, so we can do that. So let's see if we can look at the larger example of it. All right, so things begin to look familiar. We construct the path. The path, of course, using paths helper to convert a path to a specific file into the path object. We name it file. Then we have some XYZ string which contains some data, and we convert the string to the raw byte array. Then we wrap the byte buffer around the data, and then we create file channel and hope that we can use file channel to essentially open file. And so here it is, file channel right here, a file channel, a new byte channel, right? So this is the creation of the file channel object, and we pass the path and the set of modes that we want. So we want to open file for creation and writing. Now remember that these constants are coming from this standard open option, and this is new I/O library addition to Java, and obviously this is very useful, and this is basically a contemporary style of using file modes when you just open or create a file. Okay, so we have to, I think this returns back an object, so we can cast it back to the file channel, and then we can use position and say my position should be 0, or I want to position number 22, and in that position I would like to do more work. Now remember how we said available with the output data output interface. I'm sorry, data input interface. Now here we can query the buffer, right? The buffer, when you begin to write data out of that buffer, you're supposed to do this in a loop, and the loop looks like this. You say, as long as output buffer still has something to write, see this buffer output, it's named output. So I'm saying if this buffer has anything remaining to write, basically just say file channel, keep writing. And this is how you transfer all of the bytes out of the byte buffer helper object into your file by using the file channel and the helper output object. So remember that you cannot just do this. You need to remember to make this operation wrapped in this kind of loop and check for if there's any remaining data in that helper buffer object. If there is, you need to keep writing. Okay, now here's a rewind function. Basically rewinding the buffer can allow you to reuse the content of the buffer. Remember, it's an immutable object, but you can rewind and then go to a different position in the file. Remember, this position is position in bytes. This is not your record counter. This is a counter of bytes. So any kind of positioning of your record has to be done by you manually. So here if I say file channel go to position 22, it's going to advance to the position 22, and it's going to reposition simply at offset byte number 22. The bytes, remember, are counted from 0. And then similarly I will write the same information as the same information XYZ at that position. And now if right here what just happened was, right, if you look carefully at what this program does, what it's trying to demonstrate, remember that the record contains XYZ for 4 characters XYZ. So when if you want to picture what's happening here, let me just move this out and just say that what happens is that I have this file channel object, right? And I have this byte buffer, right here. Byte buffer, it's called output in my case. So I have this byte buffer. File channel uses the byte buffer when we call the method to write. Okay, but what happens here when first I go to the position 0, specify position 0, and I know that my byte buffer contains 3 characters, X, Y, and Z. And so those X, Y, and Z are being stored at the beginning of my file, right? So the positions of these characters, their actual offsets are 0, 1, and 2. But then I say, go to position 22, which is somewhere here, right? Different kind of position in the file. And by the way, this file data doesn't even exist. So again, at this new position, I say X, Y, and Z store this information. So anything in between gets filled with zeros, right? So this will contain right here, all of this will be filled with 0 bytes between these two. The gap is filled with zeros. This is what this write will do. So you have this flexibility to go to any position you want, even if the file physically doesn't have that information just yet. You can still reposition to non-existing areas of the file so far and keep writing into them. And if gaps will exist, they will be filled with zeros. Kind of interesting operation, but also very much low-level operation, because simply realize that I cannot even write a string into the file. I have to convert string to bytes, to an array of bytes, which is the lowest level of data format that you can possibly think about, raw bytes. All right, so that does it. Okay, and we keep changing the position and keep writing the information into the file. Then we close the file. Well, you know what? Let me try another project where we can demonstrate this, because it's important to actually test this and see what the outcome of this operation is. So let's try testing this.